Welcome, everyone. We didn't finish up the quiz on Wednesday, so we're going to finish it up today. And the reason I didn't want to rush through it or get through it is I want to show you a method another method for finding the equation of a line using technology. Using specifically, we're going to use the Desmos graphing calculator. So I have the tab open here. So if you go to desmos.com/calculator, it takes you to the graphing calculator. If you forget the /calculator, just go to desmos.com and say graphing calculator. It'll take you here. And this is going to do everything that we need it to do for chapter 2. The thing is this is also going to help us when we get to chapter 4. We're going to be using the same tool, and we'll be using it in chapter 3 again. So it makes the whole process so much easier. So chapter 2 is about looking at things that are a constant amount of change. That's how we get linear change. So we're going to look at this last question. And what we have here is we've got tuition costs. We're asked to, again, I usually don't start just reading the question itself. I look for what they're wanting us to do. They want us to determine a linear equation given some information. What is a linear equation? What is the standard form that we've been working with? Y equals mx plus b. Good. Where x and y are variables and they become coordinates on the graph, right? X is the horizontal coordinate, y is the vertical coordinate. So this all comes from having a point x and y and another point x and y. And when we have 2 points, we like to say, okay, how are they different? So we'll call this x1, y1. So that's the first point. Second point, we'll call that x2, y2. And there's formulas that maybe you're familiar with from a previous algebra class. We will do most of this without putting all those formulas together. So if we have 2 points, we can get this linear equation. And what we're going to do in this one, we're going to use Desmos. And then not only do we get the equation, but we'll be able to answer multiple questions about something that's different from the points we were given. So we're going to be able to do what's called interpolation, which is finding values in between the 2 pieces of data we have, and extrapolation, which is future data, future points. Okay, so let's kind of walk through this. So in 1990, the cost of tuition at Western University is $94 per credit hour. So we've got 2 things. We've got year and cost. And then we've got another one that's in 2004, which is a year. We get a cost of $248. So what we do right away is, okay, we've got 2 points. We've got 1990, the cost was $94. And typically, whenever you've got something involving time, that's going to be your x coordinate. Okay? Yeah, chapter 2. So we're just kind of wrapping up what we did from Wednesday. And then we've got the second point, which is 2004, is $248. So notice those are facts, those are pieces of data. And we often do this if we have 2 pieces of data. What we can do is assume that the change was linear or that each year it was constant, averaging it out. We're going to draw this line and we're going to be able to say, okay, if that was the case, what was the tuition in 2010, which is a future date? So that's going to become a question. We want to know how much would it cost here. And then we also want to know if when the tuition will get to 347, so that's a y value, we want to know what is the x value. So those are the 2 questions. Okay, good. Technology has not been my friend this year, so. Okay, what we're going to do is we're going to plot these 2 points with Desmos. We're going to put this in we're going to put an equation in Desmos, but I'm going to show you we're going to do it a little bit differently because of the way we put it in a table. We're going to do y1, and we're not going to use equals. Desmos, it's kind of just the syntax of how Desmos works. We're going to use an approximate symbol, the tilde. We're going to use m, and then we're going to use x1 plus b. And Desmos is going to take those 2 points, and they're going to figure out what the m and the b is, so that'll give us the equation. And then from the graph, we're going to plug in this value for x, this value for y, and we're going to get our answers right from the graph without having to do anything that feels like math, although we're using technology to do our math. Okay, and that's how we'll go forward with this. One thing before we start is in math, they give us this. They want to express the equation should be in terms of x, but what is x? X is not 1990. It is the year since 1990. So in 1990, x is 0, right? So it's just like we have the power to make any year the beginning year we want. In the old days when they had a new king or queen, that would become year 0, and they would count from the time of that king or queen. It's the 5th year of the reign of Queen Sally, whatever. Okay, so what we're going to do is we're going to revise these points. We're going to call this point 094 because in 1990 it's 0 years since 1990. It is 1990. 2004, we can get that what its x value is by subtracting 1990. So we go 2004 minus 1990, or you could count with your fingers, which I like to do. 1990 to 2000 is 10 years plus 4. Should be 14 years, and I think if you subtract it, you'll see you'll get 14. So however you want to do it, but when you get stuck, just subtract it. Subtract the years, and you'll get that this is the point 14. X is 14, y is 248. And while we're at it, 2010, since we've kind of looked ahead, we're going to have to answer that question. What year would x value would 2014 be? Or sorry, 2010. Well, 1990 to 2000, that's 10. To 2010, that's another 10 years. So this is going to be 20 years. Okay, so we'll see. We're going back and forth between these two. Okay, so now all we have to do is go to Desmos. We'll tell Desmos these are our 2 points. We'll fit our graph so we see those 2 points. We'll enter this piece of information, and Desmos will draw the line connecting those 2 points, and we'll be able to figure out all the values we need to figure out from there. Okay, let's give that a try. And if you'd like to follow along this, again, I wouldn't follow along. Your question in your quiz may have slightly different points. Use these points, but follow along in Desmos. So if you have your computer open, if you go to Desmos, I think you'll find it because you may look at it and it looks easy. I always do this. Oh, it looks easy. But when you get into do it, there's always a little something. Oh, what button did he push? But if you follow along and ask as we go, we'll make sure we're all on the right screen. So we start with Desmos. First of all, I'm going to let you know that you can, because you have a Google account, which is and again, you may have a personal one. I store all mine with my ASU and SEC all use Google email. So I sign in with my ASU account, and I'll just show you. If you click on this, I can save things, and so these are things I've done previously. And you might want to do this so that when you get to a test, you've got your equations already saved. So if you forget something, just pull up the old one. Oh yeah, it's this symbol, that symbol. It's ready to go. In fact, I've got these exponential regression. These are what we're going to do in chapter 3, this general regression. So I've got some stuff that I've used. I'm going to do it from scratch just because I'm assuming you have it from scratch. But just let you know, it's easy to log in with an existing Google account. You just pull it up if you're already signed into your Google account, and then that way you can save things. And for my classes, it is perfectly fine to reuse these. Some teachers will say you can't, the test has to be completely different. I let you use a page of notes. I let you record what you've done. I just want to see that you've worked through things. So we're just going to start from scratch. What I do is I'm going to hit the plus sign because I'm going to add something. What am I going to add? The points, because that's what I know. So points go into a table. Notice as soon as I've got a table, I've got a list for the x coordinates and the y coordinates, and it's going to graph it for me. So I put in my x coordinate as 0, 94. So it was in year 0, which was 1990, $94 per credit hour. In year, what was it? 14, thank you. It was 248. 248. So we go, yeah, I can never remember. That's why I have to go back and forth. So I like having 2 or 3 screens. You have everything up, and but we'll go there. Now, Desmos was plotting these with a green dot, but we don't see them. And why don't we see them? Well, our graph only goes up to about 7 or 8, and it goes over to 10 here in the x direction. Notice my x's are going from 0 to 14, and my y's are going up to 248. So what I need to do is I need to come to this little wrench, and I can fit my window. So my x-axis, I want it to go to at least 14, but remember I looked ahead, and there's a question I'm going to need to ask is when x is 2010, which is 20, I need to answer that question. So I'm going to go out to 30, x equals 30. I leave the negative 10, I'm not going to worry about that. And then my y-axis, I want my y to be big enough to see what's happening, 248. But remember that future question, we also want to know when is the tuition going to be 347, right? I already looked ahead and I said, okay, they're going to ask this question. So I'm going to make my window big enough to see that. How about 500? And as soon as we've done that, you now see your 2 points that we've plot. 094 is right here. That looks about right. And then this is 14, 248. Yeah, that looks about right. And so we're all good. And we're going to be, and this is a way of doing math visually. Yes, sir. I did the biggest one. So I went to, I saw we're going to go to 347. So I want to be bigger than that. So I went to 500. Part of this is just sort of a guess and check. And if you don't make it big enough, you won't see your stuff. Well, you just go back and make it bigger. It's not like a one-shot deal. You can, in fact, that's the way I learned is I didn't make it big enough. So go back and make it bigger. And that's part of it. But we just kind of look. So far, are we okay? Okay, and again, remember, what we're learning today is going to help us next week when we get into chapter 3 and into chapter 4, because we're going to use this technology again and again, and you can use it on the tests. You can also, there's an app you can download to a smartphone, Desmos, and you can use that. So that sometimes that's easier because you've got that over here, you've got your questions over here, you got your 2 screens. But it's really a cool calculator. Now what we want it to do is we want it to find that line. So what we're going to do is we're going to add an expression, which is there. It's not an image folder. It's the one f of x. It's going to give us a function. And what do we put here? We put y equals mx plus b. I'm going to do that first, but just because that's easier to remember. But you'll see nothing happens. And the reason it doesn't happen is when we look at our table, is the x coordinates, are they just an x coordinate? No, they're an x1 because it's from the first table. If we do another table, it'll be x2. So what I need to do here is I go to my x and I just put a 1. Desmos makes it a little subscript. And so now it's going to look for these x values. And then for the y, I'm going to do the same thing. I'm going to do a y1 because that's the table it's coming from. And notice it kind of gave me an error. And the reason is these are not completely equal. What we need to do is take away the equal sign. I'm going to go to my keyboard here. We want this thing called a tilde, a squiggle. If I go to the keyboard, it gives me it right down here in Desmos. On your keyboard, you'll probably see it next to the escape key or the 1 key. It might be a shifted button there. I've got one on this one, but I just wanted you to see this. If I put it in, that tells Desmos, take those 2 points and find the best fitting line, which in this case goes right through them. And there it is. There's the line. And not only that, it's given us the uh, equation of the line. It's given us what m is, the slope. It's 11. And from remembering from Wednesday, what does a positive 11 slope mean as far as the line? Increasing. Yeah. And you can see it here. See, notice how the nice thing about this is it connects all those things. Oh yeah, the line's going uphill, left to right. It's increasing. So we see it all and it's there. The y-intercept is 94, and it's showing us it right here. It's the 0.094. One of the points we had is our y-intercept. So we have the information we need to answer the first question of what is the equation. So we're going to take this, and we're going to go back, and we're going to fill in our answer. It's okay, instead of y, they're using c. We are using x. All we have to do is enter in 11x plus 94. So that's our equation. And if we check, that's exactly what they wanted. Okay, so that's the first part. So Desmos will give us the equation of the line if we've got the 2 points. And we can do this for anything, even if we're not asking this complicated question. They just give us 2 points. We can use it to find both the slope and the y-intercept. Remember this m, that's our slope. And this is our y-intercept, or our initial value, right? Okay. But the real power of this is now we're all set up to answer these 2 questions. The second question, in the year 2010, tuition will be what per credit hour? So we did it down here. It's going to be the point 2010, but remember our x in 2010 is not an x value. Our x value would be 20 years since 1990. Now we just need to find the y value, and I'll show you how you do that with Desmos. In Desmos, all we need to do is add another expression. Where is it? Anywhere. We want x to equal that number. So whatever they gave us 20, or they gave us 2010. We had to figure that's year 20. We just put x equals 20, and watch what it did. It gave us a vertical line where x equals 20. We click on the point, we got our answer. We just did the calculation. Now you could have plugged that 20 into the function, into the formula. 20 times 11 plus 94, and you would get that same value, which is fine. Or you could just do it, but notice here, we get a visual, we get the actual answer. It's calculated it for us. It's all right here. Okay, so 314. That's what it's going to be. And I encourage you to do it multiple ways. So go ahead and, okay, that's 314. Let me check. If I do 20 times 11, that's 220, plus 94, that's going to be 314. Oh, that's what that number is. You'd almost, plug it in the calculator, whatever you want, but you'll see that connection between the equation, the line graphically, and the points. So far, so good? Okay, and again, remember, this is going to empower us for the next 2 chapters after this. And then the last one, question? No? Oh, okay, okay. Last one is 347 is when will the tuition be that amount? So the question is, that's a y value, right? We're looking for what year, we're looking for the x value. So we do exactly the same thing. We're going to add another expression. This time we're going to say, tell me when y equals 347. Yeah, 347. Notice this time we get a horizontal line where y equals 347, and it's intersecting there. This is the one we want. This is our line. So in year 23 is when it'll be 347. We were looking for that x value. So we come back here, the year's 23. But that's not the answer I put here. They want to know that's 23 years since 1990. So remember, you can either kind of just count on your fingers, or you take 1990 plus the 23. That's going to be 3. 9 and 2 is 11. Carry the 1, so that's going to be 2013 is the answer we're supposed to put in there. And we check our answer there. Yep, that's true. Yep, that's true. But it's really a powerful way to do the mathematics because you see it visually. You're able to project what's the future value going to be, when is it going to, how many years before it reaches a certain value. There's a lot of things you can answer just from getting 2 pieces of data. Okay, and that's with linear. We're going to look at the same thing in chapter 3, but the change is going to be a percent change, and we're going to be able to do the same thing. If I know two data points and I know it's exponential, we'll be able to do the same thing. And then in 4, we'll put it all together. Is that good? I think we finished off. I think I may have done some of this, but remember, again, I do these, and I got 2 classes, so I think I did something, but I might not have done it for you guys. So always keep me appraised of what we need to do. But this is recorded. I'm going to add that to the chapter 2 recorded lecture if you need anything. And then, like I promised, I'll give you the rest of the time. Just work on things, ask questions. But before we split off, any other questions, especially about Desmos? Okay, very good.